Okay, so let's continue our discussion with TTP. And in particular, let's look at this problem that we had with the show-vlan output, where we had the first VLAN entry had multiple items here, which if we were just doing space-based processing, would create an extra column. So if we look at our template, and once again, remember with TTP, we have assumed regular expressions. So we have assumed regular expressions that are magically being created for us, including certain like reasonable defaults that we can assume. So the assumed regular expression, like if we didn't put this pipe digit, I remembered remember I had stated earlier that this VLAN ID would just be consecutive non-whitespace, but when we modify it with the digit, it converts it into a sequence of digits. And then remember what I said earlier about these single space, that will be converted over into consecutive white space. Now remember I said there's some nuance on exactly what these regular expressions are converted over to behind the scenes. So you can think of what I'm saying here as loosely correct, but if we're getting into the exact definition of the regular expressions, I am not clear. I think it actually is a backslash at a space and a tab can be here. So it doesn't cover any consecutive white space. It only covers a subset of that. So there is some nuance in this, but I think it's generally true. But if you want to look at the exact regular expressions, we would need to dive in to some TTP debugging and to some TTP documentation. Okay. So we have these assumed regular expressions that are creating these patterns. And notice how quickly and how nicely we can start to parse these outputs using these assumed regular expressions. And it's in a format that is familiar to a lot of us, because a lot of us are familiar with using Jinja 2. So we have these Jinja 2-like variables that can get converted magically into a certain set of regular expressions. We've already seen how using Jinja 2 filters, or what essentially look like Jinja 2 filters, how we can modify these assumed regular expressions. Now we have this problem here that this one has a space in the output. So this gets harder, and we'd have to start digging into the TTP documentation. And we can dig into the TTP documentation and start looking for how we can match different things. So if we look under match variables, we look under regex patterns, this is where the digit is. We have things like where we could match on an IP, we could match on a MAC address. There's also this thing called a phrase. And a phrase would be a collection of words that had a single space character in it. So we could potentially match on a phrase. You could think of this like a description on an interface where, it might be a phrase and not just a single word. So you could have essentially a sentence there describing the thing, which would have spaces in it. So we could just try and see, does phrase work here? Now, one thing we need to be careful of is phrase means it has to have spaces. So there's this or phrase, which means it could be a single word or it could be a phrase. So let's try to use that or phrase. So could be a single word, because we know some of these entries here, like these ones, are only a single item. But we know this higher one has a space in it. Now there's a question of, well, how does this or phrase deal with this comma? Does it include in its regular expression pattern? Is it capable of handling that comma or not? So let's go ahead and run that and see whether that works with the or phrase option. Okay, so we go ahead and execute this. We go see, did we get Ethernet 1? Okay, we did. So now you can actually see that we are getting structured data back. Now you can see there's this additional level of nesting. That additional level of nesting pertains to the fact that we could actually have multiple template files that we're using, and we could also have multiple input sources. There's also a way we can flatten that output so that nesting gets reduced. But that's also very easy to handle in your Python code, right? You can just get rid of those additional list layers very easily in your post-processing in Python. So either way, that's not that big a deal. The key item here is we now have structured data back. We are getting this output back from the device. Okay, now there's another way we could solve this, and this is actually the way I originally solved this before I experimented with the OR phrase. So let me copy and show you this because it does have some interesting aspects to it. So I'm going to go ahead and move what I have right now to this. Okay, let me move that. Okay, and then I'll go ahead and do this and paste this. Whoops. Let me move this other one. Okay, so now let's look at this. So now another thing we can do is we can actually use a straight regular expression here. So we could say RE and refer to a variable that we've created earlier, where the variable is a regular expression definition. So notice now that I've actually created sections in my template. So before I just had a definition of the parsing that we wanted to do. And now I'm starting to use tags to create sections in my template that perform various functions. So inside this group, I'm actually going to be processing the output that's coming through. And in the vars section, I'm going to be defining a regular expression for what port consists of. So if I wanted a regular expression that matched, it needed to match both this case and this case. So I need to construct a regular expression that covers that. And now we're going to get into a little bit of regular expression land. But here I said consecutive white space plus and a sequence of characters. So it's going to have to start out, since I know this is at the very end of the line, and I know it has to start out with consecutive non-white space. So that will match up to here. So consecutive non-white space, in this case, will match up to here. In this case, would match up to here. And then I say, grab everything else, since it's at the end of the line. Now, I would actually need to grab a whole bunch of more show-vlan outputs from Arista devices to see if this pattern is ubiquitous enough to work across a whole set of devices. But I know with my particular output, it does work with this particular output. So I'm saying consecutive non-white space. So that's what this backslash capital S means. Anything that's not white space. And then the plus means one or more in length. And it's going to try to grab as many as it can because by default, regular expressions in Python, which is what TTP is using under the hood, are greedy. So it's going to grab as many non-white space characters as it can. It'll get to that first white space character, which is here, and then it'll say grab everything else, which would grab this. And then in these ones, there is nothing else to grab because likely the end of the line is right after the, the number. So ET2 right here, right here, right here. Okay, so if I've constructed this regular expression correctly, that should work with all those ports. Now notice how I've used this, how I've introduced this in there. I put the pipe character, and then I've specified that we're going to do an RE. So we're going to do our regular expression. And then I've specified my variable, which I've defined in the vars section, as a string. So I put in port as a string, and I've defined that variable up there. Okay, so let's go ahead and see if that works properly. We'll go ahead and do our command again, and we'll look at our processing, and we'll see, okay, once again, I don't have the header rows. I do have all the other fields. I have VLAN 1, through VLAN 7. So I've processed them all properly. I've processed them all correctly. Okay, so once again, we have this process that we're going through where we're using these reverse Jinja 2 constructs with implied regular expressions that are sort of magically there, and with some implied white space characters that are between these regular expressions.